A concentric contraction is the type of contraction wherein a muscle contracts and shortens. The muscle generates the force that moves a body part to create the joint action that is occurring. It is therefore termed the mover. If the force of the muscle's contraction is less than the resistance to the muscle's contraction, the muscle will lengthen instead of shorten as it contractions. This is called an eccentric contraction. An isometric contraction is one wherein the muscle contracts and stays the same length. The force of the muscle's contraction is exactly equal to the resistance force. Concentric contraction of the brachialis muscle is shown here. The arm is fixed and the forearm is mobile. The arrow within the brachialis shows the line of pull of the muscle. The movement represents the strength and direction of pull of the brachialis acting upon the forearm. Note the direction of pull of gravity acting on the forearm. Now let's look at the eccentric contraction scenario. The force of the contraction of the brachialis is less than the resistance force of the weight of the forearm. Therefore, the forearm extends with gravity, causing the brachialis to lengthen. In this scenario, the force of the contraction of the brachialis is exactly equal to the resistance force of the weight of the forearm. The brachialis therefore does not succeed in shortening and flexing the forearm, nor does gravity succeed in lengthening the brachialis and extending the forearm. This illustrates isometric contraction of the brachialis. During isometric contraction, no joint action takes place and therefore no mover or antagonist exists. Resistance exercises add to the force of resistance that the contracting muscle must work against. Here's an example of a resistance exercise by adding resistance to flexion of the forearm at the elbow by placing a weight in the person's hand. Here is another example showing added resistance by using rubber tubing or a pulley system that must be stretched or pulled for the person to be able to flex the forearm at the elbow joint. Here are a couple examples of concentric contractions. With the person abducting the right arm at the shoulder joint against the force of gravity, the force of abduction is created by concentric contraction of the abductor musculature in the frontal plane. Here is another example. With the person flexing the right arm at the shoulder joint against the force of gravity, this force of flexion is created by concentric contraction of the flexion musculature in the sagittal plane. One last example. With the person flexing the right leg at the knee joint against the force of gravity, this force of flexion is created by concentric contraction of the flexion musculature in the sagittal plane. We are still adducting the arm at the shoulder joint in this example. However, gravity is the mover force that creates adduction in this case, but the abductor musculature is eccentrically contracting to slow down the force of gravity. Why is it necessary to slow down the force of gravity in this type of movement? It is necessary to slow down the force of gravity to prevent the arm, forearm, or hand from slamming into the side of the body. In this example, the person is statically holding the arm in position of abduction. In this case, the abductor musculature is isometrically contracting, equaling the force of gravity, so that no motion occurs. Does the musculature change in length during this type of contraction? No, the musculature of the joint does not change in length because no joint action is occurring.